Good morning, Numurkers, best class, and Dylan. Hope you're enjoying your isolation as much as you can. Today we're looking at solving quadratic inequalities. So earlier this term we looked at solving linear inequalities. Now, this involved looking at the symbols, say x less than or less than equal to, greater than equal to some number. So x is less than 1. If we have our number line here, then this inequality we can represent by this line here. So all of these x values here would satisfy that inequality here. Bear in mind we used an open circle there. If it was less than and equal to, so this one, we would color it in full because it would also include 1 itself. But now we're going to use, rather than linear, we're going to look at quadratic inequalities. Okay, so say we're given some inequality, x squared plus 2x minus 6 is greater than 0. So what we're going to do is we want to find all the x values that make this true. So for example, let's see if x is equal to 0 satisfies that. So we've got 0 plus 0 minus 6, which is equal to minus 6. Now that's less than 0. So that doesn't satisfy this inequality here. Alright, so what about x equals 5? Well, we'll have 25, so 5 squared, plus 2 times 5, which is 10, minus 6, that'll equal 29. Now that's definitely greater than 0. So that's all good. So we know that this would be one of the x values that satisfies the inequality, but how do we find all of the x values that satisfy the inequality? I understand my thingos here look a bit like 7s. I'm doing my best. Okay, well, how we find it, there is basically 3 steps. So let's look at question 1 and we'll go through those steps. So we want to solve the equation x squared minus 2x minus 8 is equal to 0. So this is what we've done before in the last chapters. This is just basically finding x-intercepts. And we do that generally by letting y equal to 0, and then we get something that looks like this. So what we need to do is we need to factorize. Now again, we've been working through this. What we need is an a times b that is equal to minus 8, and an a plus b that is equal to minus 2. So let's look at the factors. So we'll get a and b. Now 1 and 8 is a factor. Sorry, 1 and minus 8. But that'll equal minus 7. We have 2 and minus 4. That would equal minus 2, which is perfect. So this will give us the right answer. So we've got our a and b is 2 and minus 4. And that minus 2, we're matching up here with this minus 2 here. Cool. So we'll factorize this, so we get x plus 2 which is our a, and then we've got our x minus 4, which is our b, is equal to 0. And we know that, well, therefore x is equal to minus 2 and x is equal to 4. So that's part A. So this is stuff that we've done in past exercises, so it shouldn't be new. Question B is we want to sketch the graph. Again, this is stuff that we did in our last exercise, but let's give it a sketch. So we've got our y, we've got our x. We know it's going to intercept here at 2. Here at minus 2 and here at 4. So what else we need to do? We've got our x-intercepts. Well, we need to find our y-intercepts as well. Or intercept, I should say. Now, we know that our y-intercept is just the constant term up here. So we know our y-intercept is going to be minus 8. The third part is our axis of symmetry. Which is minus b on 2a, which is equal to minus 2 on 2 times 1. Because our b is minus 2 up here, and our a is just 1. So we'll get 2 on 2, which is equal to 1. So we know this will be our axis of symmetry here. And our fourth thing is finding our turning point. So again, we just sub this axis of symmetry value into our quadratic, which is y is equal to x squared minus 2x minus 8. Okay, so we'll get y is equal to x squared, so 1 squared minus 2 times 1 minus 8. So get 1 minus 2 minus 8 is minus 9. Okay, so we know minus 9 here, this will be the turning point. Alright, and again, it's not going to look like a good graph because mine never do, but it'll look like this. So that'll be this, y is equal to x squared minus 2x minus 8. Okay, we've sketched the graph. Now for C, what we want to do is we want to solve the inequality x squared minus 2x minus 8 is less than or equal to 0. So what we do is we use this graph here. That's quite thick. Let's make it thinner. So we find all of the x values for which this graph is below the x-axis. So if we want to find it less than or equal to 0, we just do this bit underneath the graph here. And we can check to see if that actually works. Let's just pick an x value that's been highlighted. Okay, what about x is equal to 0? Well, we've got 0 minus 8 is less than or equal to, is equal to minus 8, which is less than or equal to 0. Perfect. And you can try that with any of the x values that are highlighted here in blue, and that'll satisfy this equation here. Okay, now something just to note as well is that it includes the points of interception as well, because we have less than or equal to. But a good way to see if you're correct is you need to just sub in some x values here in the colored region. Okay, now what we do now is we've done the hard work, we just need to write our answer. So our answer would be, well, it's all x values that are less than or equal to 4 and are less than or equal to -2. So all the x values along this line here. Alright, let's try part D now. So part D is x, oh, what's going on here? Yep, x squared minus 2x minus 8 is greater than 0. So again, we just find the values that are above the x-axis. And again, you can chuck in some of the values just to see if you're right. So why don't we chuck in? So we'll pick an x value from the pink region that we've highlighted, just to check that we're right. We'll try x is equal to 5. So we'll get 5 squared minus 2, 5 minus 8. That'll equal 25 minus 10 minus 8. And that's equal to 7, which is greater than 0. Perfect. So we're on the right track. Okay, sorry, it's just moving. So again, now we need to just write our answer. So we've done the hard work, but we want to get all the marks. So we say, well, it's all x values that are less than -2. So it's x less than -2. And then it's all these x values here to the right of 4. So it's x is greater than 4. Perfect. So this is our answer here. Now it seems like a lot to do, but we've been building up our skills in the last few weeks. So your factorization, hopefully you guys are getting pretty good at that at this point. And factorizing, the only thing we're doing here is we're effectively just finding the x-intercepts. And then part B, sketching. Well, you just got to do the other 3 parts of the process. We've done step 2, now you just got to do step 1, step 3, and step 4. And then you just have to look at the graph. So this is the first 2 steps, A and B, are literally just sketching a quadratic equation. And then now you just need to be able to look at the quadratic equation and color in the appropriate bits. All right, let's have a gaze at 2A. Where did I put the textbook? Righto. Bear with me for one sec. Alright, sorry about that. So 2A, we want to solve each of the inequalities here. So we've got x minus 2, x plus 2 is greater than or equal to 0. Alright, so again, what we should do is we should sketch the graph. We know it's going to intercept at so this is x is equal to 2 will be the intercept, and this is x is equal to -2. So it'll intercept here at 2 and -2. Now, since the intercepts are kind of symmetric about this y-axis, so 2 and minus 2, or 3 and minus 3, or 4 and minus 4, we know that it's going to intercept the y-axis at its turning point. Okay, so the turning point is going to be somewhere down here, and well, that just means our life's a little bit easier because all we need to do now is find the y-intercept. So we've found our x-intercept, and we don't need to do 3 or 4 because they're done just with part 1. But anyway, that's just a little side note. Ignore that if that's just confusing you. Okay, so let's sketch the graph. Let's expand those brackets. So we're going to get x squared minus 4. Actually, I'll just do that out just to make sure everyone's on it. So expand the brackets, and this will give us x squared plus 2x, and this will give us minus 2x minus 4. These will cancel out, and so we'll get x squared minus 4. Great. Okay. So if we let x is equal to 0 to find our y-intercept, we'll get y is equal to minus 4. So our intercept down here will be minus 4. So again, you can sketch your graph. And we want to find where it's greater than or equal to 0. So you can draw it up here. And again, you can sub in a value just to check. Alright, so let's check. Let's take x is equal to 3. So we'll get y is equal to 3 squared minus 4, just from using this equation here, which is equal to 9 minus 4, which is equal to 5. And that's clearly greater than or equal to 0. So we're on the right track. And now we just need to write our answer. Well, it's all the x values to the right-hand side of 2, including 2 as well. And then all of the x values to the left of minus 2, including minus 2 itself. So that'll be our answer. All right, let's do B, 2B. So we've got x plus 4, x plus 3 is less than 0. Okay, so again, our x-intercepts, x equals minus 4, x is equal to minus 3. We can just get them from the brackets there. So we can sketch our graph. Great. Now, we've done step 2, which is the x-intercepts. Our y-intercept, let's find that. I mean, you don't technically need to do that. You could actually just do it from this point here. But since we're just practicing graphing quadratics, I'm going to do all of the steps. So we've got y is equal to x plus 4, x plus 3. And let's expand this bracket. And then I'll collect our like terms. So our x-intercept here will be at 12. So it'll be up here. Sorry, our y-intercept. We can find our axis of symmetry as well. So x is equal to minus b on 2a. Minus b is minus 7, and 2a is 2. So our axis of symmetry will be minus 3.5, which is what we expect. And then we can sub that in to find the... I should really write the steps down. And then turning point. So you'll sub in the axis of symmetry into the equation. Into this one just here. So you get y is equal to minus 7 on 2 squared plus 7 minus 7 on 2 plus 12. Alright, my computer's frozen. So that'll give us 49 on 4 minus 49 on 2 plus 12. And that'll give us some number that's negative. I can't be bothered to figure it out. Anyway, some number down here. If you have a calculator, by all means figure it out. Alright. Now we want to find for when it's less than 0. So it's less than 0 down here. And remember, since it's just less than and not less than or equals to, up here, it's not going to include the intercepts. So these will be empty circles. Now, how can we check? Well, why don't we sub in our axis of symmetry? So let's sub in x is equal to minus 7 on 2, which will give us this point down here. And we know that's going to be less than 0. Because this down here to your right is less than 0. If you chuck it into your calculator. Okay, so we've checked that the point down here satisfies it, so we're probably right. And then just answer. Well, it'll be all the x values to the left of minus 3, but to the right of minus 4. So all of these x values sandwiched between those two numbers. Okay. Now let's do 2 more quick ones. We'll do 3D. Alright, so we've got 36 minus 25x squared is greater than or equal to 0. Now, something to note here is that we have a minus in front of the x squared. So if we were to write this as a graph, that minus is going to mean that our graph is going to be a frowny face, as opposed to the smiley faces we've been looking at. Alright, so let's do the same thing we've done so far. Let's find the x-intercept. So let's take this expression, 36 minus 25x squared, and let's let it equal to 0. Okay, so what we'll do is maybe we'll plus 25x squared, and we'll take it over this side. So we'll get 36 is equal to 25x squared. And then why don't we divide by 25 now, because we want to get rid of what's in front of the x squared. They'll cancel out. So we'll get 36 on 25 is equal to x squared. Now what we can do is we can take the square root on both sides, but you have to remember that we've got to take the plus or minus here. So we'll get plus or minus 6 on 5 is equal to x. So there'll be our x-intercepts. Okay, now again, since the intercepts are symmetric about the y-axis here, we know that the turning point is going to be up here. So let's just draw the graph. We know it's a frowny face because of what we did before, up here. Now you can calculate the y-intercept, as I said above. We were kind of just doing that for practice. But why don't we actually just skip ahead, because we're getting confident now. Well, hopefully you guys are after you do your homework. So we want to find all of the x values that are greater than or equal to 0. So that'll be these ones up here that are greater than or equal to the x-axis. And remember, it includes the x-intercepts as well, because of it's got the, oh, that's a thick one. They're all thick. Because it includes this down here. So we can check our answer. A good one to check would be the axis of symmetry, which is x is equal to 0. I'll leave you to do that. But our answer, pretty confident we're right, is just these x values between these two intercepts here, including those intercepts. So everything to the left of 6 over 5 and everything to the right of minus 6 on 5. Okay. Now, one last question, bit of a tricky one, is question 6. So, we want to explain why x minus 3 squared is greater than or equal to 0 for all x. Okay, well, you could do this 2 different ways, but the easiest way is probably graphing it. So say we had y is equal to x squared. That would look like this, and it'd be graphed. So we'll graph it in red, just like this. But if we have y is equal to x minus 3 squared, we graph that in green. Well, again, that's just a transformation, which we looked at, I think, 3 exercises ago, and it moves 3 units to the right. So we'd have here. And it would look exactly the same as this red, but just shifted to the right. Okay. Now, you can see that for all of the x values, they're greater than or equal to the x-axis. So that's method 1, which is the graphing way, from what we've been doing this exercise and the last few exercises. Method 2, which might seem a little bit obvious once I've done it, is, well, what is x minus 3? Is it x minus 3 or is it x minus 1? That's x minus 3. What is x minus 3? Well, it's just a number. Because x can be any number, so a number minus a number, it's just a number. Okay. So if we have x minus 3 squared, we know that it's just a number squared. Okay. And what do we know about any number that's squared? That is shocking. So what do we know about any number that's squared? Well, we know it's greater than or equal to 0. So we know that x minus 3 is a number. We know that it's just x minus 3 squared is just a number squared. So you can consider it like, just consider it y is equal to x minus 3. Well, y squared, which is x minus 3 squared, well, y squared, no matter what number it is, it's always going to be greater than or equal to 0. If y is equal to 0, 0 squared is 0. That satisfies this. If y is equal to 1, 1 squared is greater than 0. Minus 1 squared is greater than 0. So any number squared is greater than or equal to 0. So x minus 3 is no different. If you don't get that, have a go at question 7, even if you did get it. Question 7 is part of the homework, so also have a go. Hopefully that wasn't too bad. Just a quick recap, guys. We'll go back up to the top to the learning intention. If I can draw, fuck, it's making me dizzy, excuse my French. So yeah, we can solve quadratic inequalities now. So when you're given a quadratic inequality, you can find the x values that satisfy it. So remember the hard part here, all you've got to do is you've got to find the x-intercepts, then you've got to graph it and just write the answer from looking at the graph. Alright, hopefully that's alright guys. Let me know if you have any questions, happy to help.